Okay, Math 1, we are going to start a new method of solving systems today, and it is called elimination. There's a worksheet here that I'm going to post on Google Classroom, and part of your homework is going to be these 5 problems down at the bottom. But it does give you explanations on how to do this. When you look through here, it kind of shows what you're going to do. So I'm going to go through it with you. The goal is you're going to take these 2 equations. What you're looking for with this, when you're solving systems using elimination, you're looking for something that resembles this. They are 2 terms that are opposites of one another. So like a negative 3y and a positive 3y, they will eliminate when you add down. So that's how you know if 2 equations are set up for a system using elimination. Remember, if we were trying to do substitution, we need to get one of the variables by itself. On here, you want to line them up. So if you notice, our x's are lined up, the y terms are lined up, the equal signs are lined up, and the constants are lined up. And then all you simply do is you add down. It's called elimination because, you know, like here, you're going to take 1x plus 3x, you get 4x. It's called elimination because these eliminate. They get a 0. Don't write plus 0 in here. Just cross them out. Equals, and 7 plus 9 is 16. So you're left with 4x equals 16. You divide both sides by 4 and you get x. Well, if you know x is 4, then you go back to the 2 original equations and you substitute the value of 4 into either one of them. They chose to do it into this first equation right here. So they replace the x with a 4. And then they finished writing 4 minus 3y is 7, leaving you with only a y. They subtracted the 4 over to get 3. And then they divided both sides by, should have been negative 3. I don't know why they didn't write that in here. Negative 3, and 3 divided by negative 3 is negative 1. So I will upload this to Google Classroom and you can work on that, but I'm going to go through a few examples here for you. So you look at them and make sure everything's lined up. Your x's correspond, your y's correspond, your equals correspond, your constants correspond. You know this is ready for elimination because you have a positive 1x and a negative 1x, so all you're doing is adding down. These will eliminate. 2 plus a negative 4 is negative 2y. 4 plus negative 14 is negative 10. You divide both sides by a negative 2, and you get a y to equal 5. All right, and again, we're looking for the ordered pair where those 2 lines intersect. You just found the y to be 5. Now you'll take the 5, you choose which equation you're going to use. I'm going to use this one. I'm going to take the 5, replace it here, so 2 times 5 will be 10. So I'm going to rewrite it with the 10 in its spot here. So x plus 10 is equal to 4. To solve for x, you subtract a 10 from both sides, and you get x to equal negative 6. All right, so there's your ordered pair. You can always check it when you replace it back into both of the equations and make sure that they do work when you're doing that. All right, so again, this one looks like it's set up. I have a positive 5y and a negative 5y, 5x and a negative 5x. My y's are lined up, my equals are lined up. There's my constant, so it's ready. So I'm going to add down. These eliminate. Negative 6 plus 4 is a negative 2y. 6 minus 14 is a negative 8. You'll divide both sides by a negative 2, and you get y to equal 4. All right, so there's the 4. You will again go back up here into either one of these. I'm going to put it back into this one again, the top one. So 4 goes here. I get a negative 24. So I'm going to rewrite it as 5x minus 24 is equal to 6. I add the 24 over. All right, so I have 5x is equal to 30. I divide both sides by 5, and I get x to equal 6. And again, I can replace that down here and for x and the y and see if it does equal 14 to know if my answer was correct. Okay, set up for elimination. I'm going to add down negative 2x and a positive 2x eliminate, but so do the y's, and so do these when I'm adding down, and I get 0 equals 0. As you can recall from our previous methods, when you have something that is true, this means you have infinite solutions. What that really means is that they are the exact same line. So if you were to use your graphing method, you would notice they would fall upon one another. So they intersect at every single point along the line itself. All right. Again, this is set up perfectly for elimination. We're going to add down 2x plus 6x is 8x. Your y's will eliminate. Adding down here, I get a positive 8. Dividing both sides by 8 to get x by itself, I get x to equal 1. So this time I solve for x first instead of the y, which is fine. So now I'm going to go and replace the x with the number 1. I'm going to go to this top equation again. I'm going to put a 1 right here. 2 times 1 is just 2. So I'm going to rewrite this equation with a 2 in its spot. So 2 plus 2y is equal to -4. I subtract the 2 over here. All right, so I'm left with 2y is equal to a -6. Divide both sides by 2, and I get y to equal -3. So there we go. Okay, why don't you write this down and try it on your own. Pause the video and see if you get the same answer I do. This will be our last example we go through. All right, so pause the video, write them down, try it on your own, and make sure you understand. Right, so we should have gotten -1, 5 as the intersection point between these two lines. Let me know if you have any questions, and I will upload the worksheet for you, plus you have an IXL to do on substitution. Let me know if you have questions.